Welcome back all of you. So in the previous class we completed image formation by concave mirrors. So let's see what are those. In the first situation, when the object is placed at infinity, we got the image at focus, and the type of image we got is point sized and it is real and inverted. We discussed everything in detail in that previous class. So coming to the second situation, when the object is beyond C, we got an image in between C and F. We got a diminished image. Diminished means small size. We got diminished image and again real and inverted, right? So third situation, when the object is exactly at C, we got the image at C and both are same size and also real and inverted. So situation number 4, when the object is in between C and F, the object is at beyond C, it has been magnified, the image size is bigger than compared to the object size, so it is magnified, again real and inverted. Next situation, when the object is situated at focus, we got the image exactly at infinity. Because the image hasn't been formed, we got two parallel lines. We had just assumed that those two parallel lines get meet at one point or infinity somewhere around, right? For that purpose, we have considered the images may be formed at infinity. Coming to the size, it has been highly magnified or highly enlarged, and again real and inverted. Up to 5 situations, it is real and inverted. But coming to the last and final situation, when the object is placed in between pole and focus, it is in between pole and focus. What happens is the image hasn't been formed because we got two diverging lines, right? Those two diverging lines cannot get meet. So for that purpose, we have to extend them backward and form an image that in the behind the mirror. We got the image behind the mirror, and after that, the size is enlarged. The image size is much larger than compared to the object size. And what about the type of image? Up to now we got real and inverted, but this time the rays haven't met, so we have to extend them backward to form an image. For this, we got an image. That image is nothing but a virtual and erect image is formed, right? So these are all the 6 situations we have discussed in the previous classes, right? So let's move on to the next topic now. Okay, let's continue the session. So let's start with some quick questions. Question number 1. When does a concave mirror form virtual image? When does a concave mirror form a virtual image? Virtual image. When the object is very close to the mirror, which means the object has to be in between focus and pole, you will get a virtual and erect image, right? What is the relation between the radius of curvature and focal length? The relation between radius of curvature and focal length is r is equal to 2f, right? Okay, now let's move on. Let's start the new topic now. That was nothing but Cartesian sign conventions. Cartesian sign conventions, right? So before showing the mirror problems, we must know the signs of different quantities. In physics, we follow the Cartesian sign conventions. Okay, let me draw the concave mirror first. For this concave mirror, you know those 6 situations, right? Let me draw one. Okay, let's say this is the principal axis. Okay, very good. Let's say the object is at here and the image that was formed is at here. Let's imagine like this. So you know the object now, right? This is the object. This is the image I. So we need to know the symbols that are related to this. The distance from the mirror to the object, that distance we'll consider as object distance. The distance from mirror to the object is considered as object distance, and object distance is represented by the letter U. You need to remember it, right? So object distance is represented by the letter U, and U is called the distance from object to the mirror. However, this time the distance from image to the mirror is called image distance. Object to the mirror is called object distance. It is U. Image to the mirror is called image distance. It is represented by the letter capital V. Right? Did you get those two? Very good. So U means object distance, V means image distance. You need to remember those two. Object distance, image distance. Okay. Let's say this is pole, focus, and center of curvature. Always while drawing the diagrams, we have placed the object at this position, right? So while drawing, I have started drawing the line like this, which means the rays are coming towards the mirror, right? Which means object to the mirror, and that ray will call it as the incident ray. Which ray it is? Incident ray, right? Okay. These incident rays, right? The direction of the incident ray is taken as positive, which means the incident ray, you know this incident ray, right? Very good. The direction of the incident ray is taken as positive, right? Which means you have to measure all the distances. Let's start measuring all the distances. So let's say this is focus and this is pole. The distance from pole to the focus is called small f. What is small f? Small f is called focal length, capital F is called principal focus. Right? Okay. So the distance from pole to the focus, you have to remember the first most important point. First most important point is all the distances have to be measured from the pole. Right? You want to measure which distance? Let's say you want to measure the C. You know the distance from C to P is capital R, which is nothing but radius of curvature, right? But while measuring, you need to start from pole, right? You have to go like this, right? And also you have to measure pole to the focus like this. Okay, let's start. Keep that in mind. I'll draw the diagram and I'll show you everything. So let's say this is the concave mirror. This is the principal axis, and I have placed this object exactly at this position. So this position to here, object to mirror is called object distance. So you want to measure the object distance, yes or no? And you know the incident rays are coming towards this direction, right? And if you measure in these directions, your value will be positive. But keep that in mind. Incident ray direction is always positive. But the main rule that says is you have to measure from the pole of the mirror, which means you want to measure the distance from object, which means you have to start from the pole, not from the object. Measuring from here to here is a wrong. You have to measure from pole to the object, right? So object distance is always negative in the concave mirror. Keep that in mind. Because you're measuring from pole to the object, but the direction of incident ray is toward this direction. The direction opposite, you're measuring opposite to the direction of incident ray, right? For that purpose, this direction, which means this value is always negative. U value is always negative in which mirror? Which is nothing but concave mirror. In a concave mirror, object distance is always negative. Keep that in mind, right? So let's move on to the focal length now. So here Let's draw a line. This is pole and this is focus. So focal length is the distance from pole to the focus, focal length. If you want to measure the focal length, you have to, incident ray towards this direction. If you measure towards this direction, this has to be positive. But what you're going to do now? You have to measure from the pole to the focus. You're measuring opposite to the direction of incident ray. So F is also negative. F is also negative. Okay, it's not positive, it's negative. F is also negative. Focal length, small f, is also negative for which mirror? Concave mirror. Right? Because we are measuring from pole to the focus, which is negative to the, which is opposite to the direction of incident ray. Yes or no? For that purpose. So focal length is always negative in which mirror? Concave mirror. So coming to the concave mirror, radius of curvature. So again, radius of curvature, if you find the radius of curvature, this is C, this is P. You have to measure from radius of curvature towards this direction, again opposite direction. So radius of curvature is also negative. Yes. So finally, you have to remember this thing, that is V value. V is nothing but image distance. Let's take a situation. The situation is very clear. If the object is placed at C, the image is also formed at C with the same size. So you want to measure the image size, you have to start from the pole. This is also a negative direction. So V value is also negative, right? V value is always negative in 5 situations, but at one situation, only in one situation. So let me show you that one situation. When the object is very close to the mirror, which means the object is in between pole and focus, the image formed is behind the mirror, right? At this time, the image distance is measured towards this direction, incident ray towards this direction, and you are measuring towards this direction, pole to the object. So this is taken as positive. Only at one situation the image distance is positive. Clear? So that's it. These are the Cartesian sign conventions you have to remember. So let me draw one by one. Let me show you one by one in detail. So F is nothing but focal length. Focal length is negative. U is nothing but object distance, is negative. And what about R? R is nothing but radius of curvature, is negative. V is negative for 5 situations, but it's only at one situation, which means if the image is real and inverted, it is always negative. If the image is virtual and erect, and that distance is positive, which means when the object is placed in between focus and pole, at that point what happens is the image distance is positive only at one situation. So remaining all the situations it is negative. Clear? Okay, everything is okay, but if you consider height of the image and height of the object, which means if the object is at this direction, which means this is considered as the height of the object, HO, then this is considered as height of the image, height. If you measure the distance, you have to measure the distance from principal axis. Above the principal axis is taken as positive and below the principal axis is taken as negative. Did you get my point? Which means H naught is always positive in concave mirror because we place the objects infinity, beyond C, at C, between C and F, at F, between F and P. Always you have placed the object on top of the principal axis, right? So you have to measure from above the principal axis, that value is always positive. So coming to the image formations, in the first situation the image is formed. For infinity it is at focus, beyond C it is in between C and F. Okay, this is focus, and after that it is in between F and P, at C, beyond C, then at infinity. So if you observe all these situations, the image that is formed is always below the principal axis. So height of the image is always negative because you have to measure the distance from below the principal axis, and that value has to be taken negative, right? But at one situation when the object is in between F and P, the image formed is behind the mirror, and that value only positive. Keep that in mind. When the image is virtual and erect, and the height of the image is positive. Did you get my point? What I'm saying now? Okay, that's it. It is little bit confusing, but don't get confused. Okay, so let's see the most important formula, and that formula is mirror formula. Which formula it is? Mirror formula. So mirror formula is the distance between, it is the relationship between distance, image, object distance and image distance, and along with the focal length. So the formula is 1 by f is equals to 1 by v plus 1 by u. Right? Here f represents, f is called focal length, v is called image distance, and u is called object distance. Right? We have already discussed what is called object distance. Object distance is the distance between object to the mirror. Image distance means distance between image to the mirror. F means focal length, that is the distance between pole and focus. Right? So let's say, let's do a simple numerical that was related to this mirror formula. So we have a concave mirror. Okay, let's draw a concave mirror here. Okay, and observe the question carefully. We have a concave mirror and it has a focal length of, let's say it has a focal length of, focal length is the distance between pole to the focus. It has a focal length of 15 centimeters. An object is placed 30 centimeters, which means at C, because 2 times of the focus will get 30 centimeters at C, that too in front of it. And find the image distance. You'll get the value again at 30. Okay, let's see. While drawing, you'll get the answer very easily. Okay, let's start finding the answers. So he had given focal length is equal to 15 centimeters. But you have to measure the focal length toward this direction, and this value has to be taken negative. And object distance is 30 centimeters, and object is at this direction. You have to measure towards this direction, again negative, right? So the formula is 1 by f is equal to 1 by v plus 1 by u. Okay, if you substitute these values, you'll get 1 by minus 15 is equal to 1 by v plus minus 1 by 30. If you replace the terms, what do you get? So 1 by minus 15, it will come here, and it becomes 1 by plus 30 is equal to 1 by v. So we'll continue here. What do you get? 1 by v is equal to minus 1 by 15 plus 1 by 30. So if you do the LCM for 15 and 30, in 15 table it goes for 1 time and 2 times. So the LCM is 30. So 1 by v is equal to, in 30 table, minus 1 into 15 table, 30 goes for 2 times, plus 1 into 30 table, 30 goes for 1 time. So minus 2 plus 1 by 30, which is nothing but minus 1 by 30. So 1 by v value is minus 1 by 30. So 1 by v is equal to minus 1 by 30. If we make it upward, v is equal to minus 30. Minus 30 means the image is below, which means you have to measure towards this direction. Above or below, we have discussed about it. Which means the image is formed 30 centimeters in front of the mirror. Did you get it? We'll do all the form problems that are in the textbook, and after completing the concept, we have many examples and also many exercise questions. So the question that has been asked in the examination, that has to be from the textbook. If the question is asked in the textbook, you have to prepare it, right? So out of the syllabus you'll get all the problems that too from the textbook itself. Is that clear? You have to prepare every problem, every example problem that was present inside the textbook. Clear? Okay, I'll make sure and I'll explain everything, every problem in detail. Clear? Don't get confused about it. So let me share one more formula that is nothing but magnification. Magnification has two formulas. M is equals hi by h naught. Hi means height of the image and h naught means height of the object, which is equals minus v by u. In some situations, they won't give heights, they only give image distance and object distance. For that purpose, you can use these two, right? Okay, hi means height of the image, h naught means height of the object, m means magnification, right? So sorry to say here m has to be small letter. I have put capital letter. Sorry for this. M is equal to hi by h naught. M is small m. Small m is nothing but magnification, which is equals to hi by h naught. Hi means height of the image by height of the object. And if you modify the formula, you'll get minus v by u. Keep that in mind. In many problems, you are going to combine these two formulas and do the sums to get the final value, right? So okay, remember these three formulas at a time. M is equal to hi by h naught or equal to minus v by u. So you have to remember the rules of the magnification. Rules. Rules means magnification. What is called magnification means? It means magnification says whether the object is small or bigger, you are considering only the size of the image now. If the size of image is same, right? If the size of image is same, m value is equal to plus 1, which means with same height and same time, right? So keep that in mind. If m is negative, the image formed is real and inverted. Real and inverted. Because in many questions, 1 mark questions, they are going to ask if m is negative, what type of image it is formed? It forms a real and inverted image. If m is positive, it forms virtual and erect image. It forms virtual and erect image. It just depends, right? And also you need to remember one thing. If n value is equal to 1, it is same size. If m is equal to 1, it is same size. If m value is less than 1, which means below 1, 0 0.5, 0 0.7 and these values, right? So less than 1, it is diminished. While writing the characteristics, you have to write all these things are diminished. Diminished means if m value is less than 1. If you get the m value that has been greater than 1, the image formed is enlarged image, right? We have discussed many rules and regulations that are related to the magnification now. So first rule, if m is positive, it is virtual and erect. If m is negative, it is real and inverted. If m value is plus, okay, not plus, is 1, it is same size. If m value is less than 1, it is diminished. If m value is greater than 1, it is enlarged. Right? Keep all these things in the mind, right? You have to remember everything in detail while doing the problems, right? Okay, let's do a simple numerical that was related to the magnification. And in the examination, they are not, sometimes they might ask the magnification question separately. And in many situations, they are going to combine these two, which means lens formula and the magnification. They both combine these two and give asked in one question only, separate question, right? So let's see the numerical problem that was related to the magnification. So he says the height of the object, which means the height of the object is 5 centimeters and height of the image is 10 centimeters. Find the magnification, right? So you have to remember the values. The height of the object is towards upward direction, it is taken as positive, and the height of the image is taken in the downward direction, it is taken as negative, right? So let's do the magnification. You know the magnification, m is equals to hi by h naught, right? It means height of the image by height of the object. So let's substitute the values. M is equal to hi minus 10 by h naught, 5, 5 1 za, 5 2 za. M value is equal to minus 2. Keep that in mind. If the value is greater than 1, right? Don't consider minus. Minus is different, 2 is different here. So minus says one property, 2 says one property, two properties. 2 says if the value is greater than 1, the type of image that is formed is enlarged image is formed here. Enlarged image is formed. What about the minus? Minus indicates the image formed is real and inverted. You get my point? If you get plus 2, we'll say 2 is nothing but 2 says it is again enlarged. Okay. Plus indicates the image formed is virtual and erect. It just depends on this. Clear? So most important questions for examinations or 1 mark questions, write the mirror formula. What is mirror formula? 1 by f is equal to 1 by v plus 1 by u. That was most important question. And write the magnification formula. M is equals to minus v by u. Right? Keep those. What is the sign for focal length of concave mirror? In a concave mirror, focal length is always negative. Right? We'll discuss about the convex mirrors in later. Right? Later sections. What is the magnification? Explain. Magnification is the ratio of height of the image to the height of the object. And the formula m is equal to hi by h naught. Or else you have one more formula minus v by u. Why do we use sign conventions? So that was the next question. Why do we use sign conventions? Sign conventions help us correctly represent distances and solve numerical problems using formulas. What? Sign conventions help us correctly represent the distances and solve numerical problems using formulas. Right? So that's it about today. So while tomorrow we're going to deal with convex mirror ray diagrams, image formations, and also some applications. Clear?